explaining the fourth problem. And yeah, so let's start. So problem one, let A, B, C, D, and E be the roots of the polynomial x to the 5 minus 2x to the 4th plus x cubed minus 2x squared plus x minus 2. And we want to find the value of 2a plus 3 times 2b plus 3 times 2c plus 3 plus 2b, 2d plus 3 and times 2e plus 3. So has anyone solved the first problem yet? Type in chat. Okay, so let's start by calling the polynomial p of x. And so we have that we know that what p of x can also be represented as, because for any polynomial, let's say, I don't know, q of x can be equal to x minus root 1 times x minus root 2. And guys, please stop writing things on the whiteboard.
Hey, hello. Sorry, could you just pause you for a
No,
little
okay.
bit? Okay. So no other kids like, draw anything on the whiteboard except for Keji, okay? Keji is the host. So Keji's gonna present the problem. Did you hear that? So no other students like, draw anything on this whiteboard. Keji, continue, please. Thank you. Yeah.
Yeah, okay, I'll just clear the whiteboard. All right, so for any polynomial, let's say q of x, that is equal to x times x minus the first root times x minus the second root, and so on and so forth. And that is because of the fundamental theorem of algebra, where we get that the for whatever x value we have, that value minus every single root multiplied together, that will give the entire value of the polynomial. And so we kind of want to manipulate the original expression into what we want. So we kind of want some value minus a times some value minus b. So we start by dividing the entire thing by -2 to get something minus a, and so on, right? If we divide everything by -2, we get a nice value, which is -3/2 minus a, and then -3/2 minus b, and so on and so forth. And then so what do we all see? Because this is just equal to p of -3/2, and that's equal to that. And then and we're pretty much done with this problem, because after we just need to find p of -3/2, and then we multiply this by -2 to the 5th, because we already divided by -2 for every single term. And so and we all just need to find -32 times p of -3/2, and that is equal to -32. I'll just spare you guys the calculation. That is equal to -32 times -931/32. The 32's cancel out, the negative signs cancel out, and we are left with a value of 931. And that is our final answer. Alternatively, you could also expand the desired value and use Vieta's formulas, or it could factor the polynomial, but I won't go into these details. Someone asked in chat how they got 932, but I think that will be a calculation error. The answer is 931. All right, moving on to the second problem. Problem 2, what is the value of the cube root of 2 plus 11i plus the cube root of 2 minus 11i? So we set whatever we want to x. I'm not going to write the full expression down. We're going to cube the entire expression. So we have that x cubed is equal to 2 plus 11i. Okay, I'm going to clear whiteboard. We're going to set that into x, and we get x cubed is equal to 2 plus 11i plus 2 minus 11i. And then we have plus the 3 times cube root of 2 plus 11i squared times 2 minus 11i. And then plus 3 times the cube root of 2 plus 11i times 2 minus 11i squared. Is everybody familiar with this step? If not, type in chat. I can explain further. Okay, I'm assuming no questions. All right. Cool. So then we can cancel the 11i's out. And then we can factor the bottom two expressions. And thus we have that x cubed is equal to 4 plus 3 times 2 plus 11i, the cube root, sorry, of, and then 2 minus 11i. And then we multiply this by the cube root of 2 plus 11i plus the cube root of 2 minus 11i. And then, so what do we realize that this thing on the right is equal to? That is just equal to x, right? Because that is a value that we're also trying to find. And so we also know that 2 plus 11i times 2 minus 11i is 2 squared times minus negative 121, or negative 11 squared. And that's because 11i times 11i is equal to negative 121. So we're having this is 4 minus negative 121, which is 125. And the cube root of 125 is equal to 5. So we get that x cubed is equal to 4 plus 15x. Is everybody familiar with the step? And does everybody understand? All right, I think we're good. So I'm just going to clear this whiteboard. We get that x cubed is equal to 4 plus 15x. And so we can employ a factoring trick here. So we don't really like this x cubed term. We can't like really solve cubic equations. So we subtract 64 on both sides. We get x cubed minus 64, which is in factor form, x minus 4 times x squared plus 4x plus 16. And no, I did not miscalculate. And that will be equal to 15x minus 60, which is 15 times x minus 4. And so we either get x equals 4 or x squared plus 4x plus 16 is equal to 15. But that will give x squared plus 4x plus 1 equals 0, which we can try to solve this. X squared plus 4x plus 1 is equal to 0. But then we will get invalid solutions, and thus x equals 4 is the only solution, and then we're done. Does everybody understand? Yeah, so now we have problem 3, which is presented by Nathan, and I'll just hand the whiteboard over to Nathan.
All right, hi, I'm Nathan. I'll do problem 3. So problem 3 is basically how many 10-digit sequences can you make by only using 1, 2, 3,
Oh, no,
4?
Nathan, sorry, I just paused you like for a while. You need to click the button, eyes on me. Okay. So
Where?
everyone can follow you. Yeah.
Where? Where's the button?
It's on the right top corner, top right corner. Can you see it?
Where? I don't see it.
Click the 2 down arrows thingies next to the
Okay.
pictures.
Okay. So how many 10-digit sequences using 1, 2, 3, 4? Multiples of 3 cannot be adjacent to multiples of 2, and the product of 2 adjacent digits cannot be a square. So basically, we list out all 4 numbers. So 1 can only go after 2 and 3, and 2 can only go after 1 and 4. 3 can only go after 1, and 4 can only go after 2. And we can basically combine these into a single group because they have the same properties, and these into same group. And we can use recursion by making 2 sequences an. Let's call an the number of sequences, n-digit sequences that end in 1 or 2. And bn, which is the number of n-digit sequences that end in 3 and 4. So we get the relation that an plus 1 equals an plus bn because bn because it can only come after a symbol in b, which is 1 or 2. and bn plus 1 equals an plus bn because they can come after both a number in an and a number in bn. Wait, what part do you not understand? Because people are saying IDK in chat. So which part? Oh, okay. First problem, okay. So wait, what do you mean question one? Oh, um, yeah. Okay, anyway, so because of these two equations, we can get this table, which I'm not gonna write out. I'm just gonna show you the table. That's the table. And when n equals 10, we can find that an is 178 and then bn is 110, and you can just add them to get to 288, which is the answer. Yeah. Did everyone understand this? Uh, type in chat if you don't understand. So I take it that everyone understood this. So Yichen is gonna do number 4.
Okay, I guess I'll start on problem 4. So, did anyone solve problem 4? Just wondering. Okay, I guess that's a no. I'll take it. So, just saying this is the graph for number 4. I'll just put it here so it makes things a lot simpler. What are people saying? Oh, never mind then. Okay, and basically problem 4 is saying that you have this isosceles right triangle.
Should I clear the rest of the whiteboard?
No, it's fine. Just leave it there. Like it's like that way people can still see it.
Oh wait, you can do the all hands on me thingy.
Oh yeah,
So that people don't follow anyone else.
So wait, someone's presenting? Whatever. Okay, so problem 4 basically states that there's this isosceles right triangle where it's inscribed in a circle. Oh, well, I mean it's not like exactly right, but like since like AB is like a diameter, then that what the like since then because AB is like a diameter, then that means that like then ACB is a right angle because AB is the diameter, and then please stop texting stuff on the whiteboard. It's please stop testing stuff on the whiteboard, please. It's annoying. And don't remove the whole thing. Okay, whatever. Okay, so it's basically saying that this is a graph, right? And then they want you to find tan AFE. And basically what to do here is that this problem is pretty much like not possible to like solve in in time without using the tan subtraction formula. So I'll first go over that. So basically tan subtraction formula states that tan A plus B, just using Greek letters here. This is equal to tan A plus tan B, and then this is the whole thing over 1 minus tan A tan B. Now this one is crucial here because we're not given much angle. So the only thing we can use is the subtraction formula, or unless, I mean also sides though. So we basically figure out that angle AFE is this angle right here. And now we have to try to like find this angle as a difference of two other angles. And after some pretty simple angle tracing, we get that angle AFE. Let's type now. Now AFE angle AFE is just answering this question in the chat, but the AMC10 has no trigonometry, but the Mathdash actually does, and plus this problem is actually solvable without trigonometry though. So like yeah.
Oh, actually, AMC does, does require a little bit of trig knowledge. But it not necessarily for that problem you have to solve with trig knowledge, trigonometric knowledge. But if you have that knowledge, then you're gonna solve the problem much faster, especially for the last five, especially when it comes to geometry problem.
Okay.
Oh, yes, continue, please.
Okay, so yeah, this problem is solvable without trigonometry, but it's very synthetic and it involves dropping altitudes. If you guys want, I can show it, but like it's really complicated. So I'll go back to this. So angle AFE by angle tracing is equal to angle BEC minus angle DAC. Yeah. Now if we just apply this formula, then all we have to do is just calculate the tangents of those angles. So it's equal to BEC minus DAC. And you already noticed here that here is subtraction and not addition. So if this was subtraction, then I'll just do this. So if it was subtraction, then for example, tan A minus B, then it will be tan A minus tan B, and then 1 plus tan A tan B. So basically, that's what we apply here. And then here, to calculate tan BEC and tan DAC, I mean, you already have like the side lengths of like DC to DB and also CE to EA. So then they're also ABC is also equal to BC, right? So on cover, what's your question?
How did you get like it's AFE is equal to BC minus DAC?
Okay, so I guess I'll explain it then. So as you know, like by the exterior angle theorem, is it called? This angle BEC is equal to angle EAF plus angle EFA. And that's because this angle BC is 180 minus like AEB, right? And then 180 minus AEB is just this angle plus this angle. So that's how we get that. And then just applying this, we get that tan BEC is equal to 2. Yeah, just BC over C, that's 2. And then tan DAC should be equal to 3/4. Is that a question or something? Tan DAC is 3/4. And then if we just plug these values into this formula over here, then you just get tan A minus B is 1/2. And then yeah, the answer is just 2 times 1/2, which is 1. So the answer is basically 1. And now does anyone want to see like a method without trig, or should I just like move on? Okay, now since many people had questions about number, wait, so George, you're saying that you would like to see the like method without trig? Oh, okay then. So this method is gonna be a lot more complex though. Like it uses things like mass point geometry, which I'm not sure that all of you know. But to start off this method, you would have to drop an altitude from E to AF and like this. Now over here, the next step in this method is to figure out that, well, let's say this point is G for convenience, and then you could see that triangle AGE is similar to triangle ACD here. Triangle AGE is similar to triangle A. What was that? What is this? And then because we know this, we can now find AG and GE. Now, we know that like AE is equal to half AC, and then we also know that AD is equal to 5/4 AC by Pythagorean theorem. So then we can AE then the ratio between these two similar triangles would be 2 to 5. And then knowing that, we can just calculate the other side values like AG and GE based on the length of AC. And we then by similar triangles we get that AG is 2/5. Wait, that's correct. Yeah, it should be 2/5 AC, and EG is 3/5 AC. I mean, no, 3/10. What am I doing? Okay, yeah, just assume that that's a 10. Okay, and now for the next step, we would want to calculate GF, but that's not very easy to do at this point. So now we can apply something called mass point geometry, like to like calculate the side lengths by assigning masses for the points. So like basically, how mass point geometry works is that like for example, like in this picture over here, right? We have like these sides. Then for example, like if here, for example, if like for ABC here, if like AB, so like over here, AB to BC should be equal to the assigned mass at, should be equal to the assigned mass at C. Assigned mass at C over assigned mass at A, I believe. Is this correct? And then here we can assign masses to the points now. And then here to assign masses, for example, because here just we can let C be have mass 1 and A have mass 1, and then let B have like mass 3. And then using this, that would have mass 2, and that would have mass 4. And then basically point F has mass 5. And then we can now calculate AF. Now AF would be equal to 4/5 of AD because like the mass is 1 there and that's 4. So then we know that, I keep writing AF 4/5 AD, and then that would be equal to AC. Okay, and then wait, something. Well, is math sting on MC10? Well, math stingy is not exactly, but like knowing it does help with solving some problems that otherwise would be very tedious to bash out with Seba's theorem. So I mean it helps, but it's not exactly on. And then like if you just like complete this long calculation, then you would eventually get that EG to GF is equal to like 1/2, and then yeah, just like do that. Like that's like the method without trigonometry. It's also a very complex though. Okay, and now I guess I'll clear it. And since many people had questions about problem 1, I'll give it back to Keji so he can talk about problem 1.
All right, sure. So again, problem 1, as a refresher, we have that we want to find 2 times whatever the roots plus 3, and then all multiplied together. So, right. So I would firstly start with the original method. I'll go over it a bit more deeply. So let's say for any polynomial, I don't know, f of x will be equal to x minus the first root times the x minus the second root times all the way to the last root. Does anybody have questions on this? If yes, type in chat. No? All right, perfect. So that would be okay, darker pen. All right. Sure. All right, so that will be our first step. And then we already defined our P of X. P of X is our original polynomial. And then we want we want to convert 2a plus 3 to something, whatever value this is, minus a, because we want a to become one of these roots. And so if we convert everything to in this format, then we can actually just find this value very, very easily. And so we can do this by dividing by -2, because the coefficient in front of a is currently 2 right now. And since 2 over -2 is equal to -1, this will probably be a very intuitive thing to use. And so 2a plus 3 over -2 is equal to -3 over 2 minus a, and then we have to multiply a -2 to the 5th in P of X. And so that is that. So basically now we have just converted everything to P of -3 over 2, since we know that -3 over 2 minus a times -3 over 2 minus b, etc., multiplied by 2 to the -2 to the 5th will be equal to the P of -3 over that will be equal to our original value. And so that would be -2 hang on. That would be -3 over 2 minus a, and then times all the way blah 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 blah. I'm not gonna write all of it. And so that multiplied by -2 to the 5th. And then desired, and then we need to we don't multiply -2 to the 5th now, but we need to multiply it to get the desired value. So we kind of just zoom out a bit, and I'll just get some space. All right. So now we have our original, and to find P of -3 over 2, that will be -3 over 2 to the 5th minus 2 times -3 over 2 to the 4th plus -3 over 2 cubed. And someone asked me why I got 931. I'm just gonna write all the steps out so that nobody gets confused. Get some more space. And then minus 2 times -3 halves squared plus -3 halves minus 2. And so we get this expression that would be equal to -243 over 32. And so if we subtract 2 times that, we get a denominator of 8 over here. And that's minus 81 over 8, minus 27 over 8, and then minus, that would be -9 halves, I believe. Yeah, -9 halves, minus 3 over 2 minus 2. And so that will evaluate to -243 over 32. And then minus 81 over 8 minus 27 over 8, that will be -108 over 8, which, and we divide 4 on both sides, that will be equal to 27 over 2. This will evaluate to -6, and thus -8. And so if we find a common denominator, which is -32, -243 over 32 minus 27 over 2 is equal to 27 times 16, which is 144 times 3, 432, make 243 minus 432 minus 256 all over 32, and that'll be equal to negative 931 over 32. And then when we multiply negative 931 over 32 by negative 32, we get 931. Is anyone unclear about this, or are we done? All right, it seems like there are no questions. I believe that that is all the questions. Thanks for coming to this week's Mathdash, and I guess I'll hand it over to someone asked for the roots. Sure. We could just factor the polynomial into x x minus 2 times x to the 4th plus x squared plus 1. And so I'm gonna have to use roots of unity here. And so we know that x squared is a root of x squared plus x plus 1 equals 0. That's the x squared is a root of this. And so does anybody have questions about this? No? Okay. And then the roots of this are I'm gonna express these in polar form. That will be equal to 1 2 pi over 3, and that's in a complex plane, 1 4 pi over 3. And since x squared is equal to these two values, the magnitude won't change because it's 1. And so and so we already know the first root is 2. Oh wait, okay, I'll explain polar form if for those who don't know. And so consider like consider like a plane, and we have a unit circle here, right? And we know, does everybody know about radians? I'll explain radians as well. So we know that a unit circle has a circumference of 2 pi. And so 1 radian is basically the amount of angle, the angle that, say, that the circle's arc encompasses for this length from 0 to this angle, this is equal to 1. And so this is 1 radian. Does everyone understand? And so 1 degree, and so because a unit circle is also 360 degrees, the conversion factor would be 2 pi over 360. And thus, this is actually 120 degrees. And this is 240 degrees. Does everyone understand? Okay. So x sub 2 would be 1 pi over 3. X sub 3 would be 1 2 pi over 3. X sub 4 would be 1 4 pi over 3. And the fifth and last root will be 1 5 pi over 3. And so, obviously our first root is equal to 2 already. And so those are our 5 roots. And Kyle, does that answer your question? Okay. And I think that's all the problems for today. Would I hand it back to our host? And that's it.
Okay. Thank you, Keji and Yichen and Nathan. Okay, so yeah, thank you for the presentation. Yeah, it's very good. So we're gonna end. So anyone have any questions? If don't have any question, we're gonna end the meeting. So Edward, can you please help end the recording?